So this is a question about what's called a matched pairs. So the way that we know it's a matched pairs test, they gave us the data. There's the same number of data values, so kind of like a before or an after. The other way is they just kind of told us. The only time we do a matched pairs test is if we are subtracting the first list from the second list. So one easy way to do this is type in all of these numbers into list 1, type this into list 2 and subtract, or I can just do it one at a time by hand. So what I did, since you had the numbers there, and I didn't feel like typing in all these numbers, I just typed in that subtraction list into stat edit. So in my list 1, I've got all those numbers. So let me kind of go through the different stages here. But just make a subtle point. Even though this is a two-sample test, a matched pairs test is a special case of a one-sample test. So we take the 2 samples to generate a sort of third list, and we do a one-sample procedure on that third list. So once I've got the difference numbers, that's all I care about are those differences. I don't go back and look at the original set of numbers. So first question is to calculate the mean and standard deviation. And so the nice part is, if you go to calc, you can do 1var stats, tell it to calculate into list 1, make sure the frequency list is left blank for this case because we're not using that, and then we're going to calculate, and it will do all the number crunching for me, and it'll tell me the mean. And now the next question is, well, how do I know whether it's the first standard deviation or the second one? And since we're dealing with what we assume to be a sample, then we're going to go with the sample one, the 1.7, instead of the 1.59. If I happen to know for a fact that these 8 observations are the entire population I could ever deal with, then I'd want to go with the population one. But usually with sampling processes, we completely ignore the population one. Anyway, so that's where they're generating those 2 numbers. Then we get the p-value, where are they getting that from? So let me go back over to my tests, and under test, again, matched pairs is a t-test instead of the 2-sample test. It's going to be a 1-sample test, the t1. And I'm just going to tell it to pull everything from the raw data, and it's going to ask me for what's your null, and I expect it to be 0, because I expect if there's no change between before and after, I expect the average to come out to be around 0. Then I'm going to tell it my numbers are in list 1. That's fine. Frequency is 1. 1 or blank, depending upon your model of calculator. And we want the alternative to be less than. So let me select that one. And then I'll go ahead and hit calculate. And it will generate our p-value, which is the 0.003 that we ended up getting. Now, just word of caution, I noticed that you typed in a negative number. P-value refers to probability. What percent of the time would I expect to see these 8 observations, assuming that the original sets of numbers, there was no difference before versus after. Okay, and so what this p-value tells me is 0.003, or less than 1% of the time, almost 0% of the time, I would expect randomly to see these 8 numbers that I end up having here, this negative 1.7, this negative 0.7. In other words, it's not random. It's not due to random chance. There's something else going on that's making the 48.1 become the 49.8, and the 47.7 become the 48.4. There's something impacting these 2 lists very strongly. I don't know what it is, but I know there's an impact there, is what that 0.03 means. Okay, and so because I have that p-value, that's very statistically significant. There is enough evidence that there actually is a difference that's less than 0, and so that we would reject the null, especially at a 0.05 level of significance. And the last question here is compute a confidence level about this. So again, let me go back to my tests, and this time I want to pull a t-interval. Since I did a t-test, I want to pull a t-interval, and again I'm going to tell it to go to the data. It's going to ask me where do you put your data, and I happen to put it in list 1. Frequency is fine, and we want a 95% confidence level. So then I'll go ahead and calculate there. And ta-da! Those are the two numbers. So negative 3.76 and negative 0.9146, which is what matches there in the final answers. So anyways, hopefully that helps.